One of the biggest dilemmas I've seen in organic chemistry is deciding between Sn2, Sn1, E2, and E1 in specific reaction conditions. Throughout this video, we'll be going over every single scenario where every possible reaction can exist and why one would be predominant over the other. Let's start off with the most confusing one. If our alpha carbon is secondary. If our alpha carbon is secondary, theoretically, every single reaction can occur. It can undergo Sn2, it can undergo Sn1, it can undergo E2, and it could also undergo E1. Now, Sn2 and E1, they exist under specific conditions. If we're using a weak nucleophile or even a weak base, so this would be something like, let's say, water, then we would be undergoing Sn1. We could also undergo E1, but only if heat exists, predominant form. Because as we know, heat drives elimination reactions. Now, if it's a strong nucleophile or base, then it can undergo Sn2 or E2. Now let's narrow this down even more. There's three possible reaction conditions. If we only have a nucleophile available, if it's a strong nucleophile, so that means its pKa, the conjugate acid, is greater than 11, then this would be Sn2. If it's only a base, and this base is, let's say, either small and strong or bulky, this would be E2. And if we have both a strong nucleophile and base, it can undergo Sn2 or E2. And this is where we would be able to break it down even more. If our solvent is protic, so a hydrogen bond donor, then E2 predominates. Aprotic would be Sn2. And if heat exists, E2 predominates. Now, we've gone through the most complicated one when our alpha carbon is secondary. Now let's go over if our alpha carbon is primary. If our alpha carbon is primary, it can either be Sn2 or it can be E2. This one's pretty simple. Sn2 will always predominate except if it's a bulky nucleophile or base, if the base is not a nucleophile and only a base, E2 only, or if heat exists, E2 is favored, predominance. And finally, the last one, if our alpha carbon is tertiary. It can be Sn1 or E2. So if it's a weak nucleophile, then it's Sn1 or E1 if heat exists, predominance. Now, if we were to use a strong nucleophile or base, there's 3 different outcomes. If it's a strong nucleophile, this pKa of the conjugate acid would be less than 11. This would favor Sn1. One thing to note, it's not necessary for you to look at the pKa table every single time you want to determine if a nucleophile is weak or soft. Sometimes an eyeball is enough. So if you notice a negative charge, 9.9 times out of 10, that's going to be a strong nucleophile because it has excess electrons and obviously wants to remain stable and be neutral. Again, a weak nucleophile is also the same way. For example, if you take anything with a hydroxyl group, most times it would be a decent nucleophile, a moderate nucleophile, or a weak nucleophile. But the chances of the alcohol being as electronegative as it is, liking to hold on to its electrons already as it is, it's unlikely for it to act as a strong nucleophile and attack less reactive things than something with a charge would react with. So pay attention to the charges. If you don't feel like using your pKa table, pay attention to your charges, pay attention to the delocalization within the atom, and also pay attention to the electronegativity of the atom if no charge exists. So if it's a strong base, then the pKa of the conjugate acid has to be greater than 11. And if it's only a base, it's E2 only. And I forgot to add, E2 predominates. And just like that, we figured out every single scenario. In the next video, we'll be going over actual problems that we can apply this cheat sheet to. So again, to add, when we're using a secondary carbon, if it's a weak nucleophile or base, we're going to be doing Sn1, and if heat exists, it would be E1 as the predominant form and Sn1 as the minor form. If we're using a strong nucleophile or base, it would be Sn2 or E2. And if we're using a primary carbon, it would be Sn2 or E2. And if we're using a tertiary carbon, it would be Sn1 or E2, and even possibly E1. Thank you for watching.